Hello, everybody. Hope things are going well. This particular set of notes and problems at the bottom I have attached, but I also wanted to do a verbal explanation. I'm calling this Day 2 probability. It's mainly emphasizing a deck of cards. Monday, I'm going to deal with dice using Yahtzee. I hate that we're missing the school because this was the time period, or actually last week was the time period I'd planned on doing blackjack and craps, so you guys going to prom understood what you were doing. But I'll just try to do it with Yahtzee. Hope everyone knows how to play Yahtzee. If not, I'll explain that on Monday. But anyway, this was a deck of cards. Reminder, probability. Number of wanted outcomes, and you really need to think about the number of wanted outcomes over number of possible outcomes. Okay? Deck of cards. For those that are not familiar with cards, I want to give you the facts about the deck of cards. There are 52 total cards. There's 4 different suits: hearts, diamonds, spades, and clubs. There are 13 of each suit. Every suit has an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And that adds up to 13 total. So there's 13 hearts of all these. There's 13 diamonds of all these. There's 13 spades of all these. And there's 13 clubs of all these. I would like to mention that in most card games that you play, most of the time an ace can be considered high or low. So like this is a 2, 3, 4, 5, 6, 7, 8, 9, 10. Jacks are usually considered value of 10. Queens have a value of 10. Kings have a value of 10. And then aces usually can go both ways. You can consider an ace to be an 11. Or you can usually consider an ace to be a 1. So it's called high or low. If ace is high, it's considered an 11 and it's better than a king. And if ace is low, then it's a 1 and it's below the 2. Okay? We're going to consider ace to be high or low. Always consider ace to be either one when we do our examples. Okay, example. This is going to be a blind draw. Pretend like the cards are upside down, and you're going to pick one card. Monday, we're going to pick multiple cards, like pick 2 cards, or we're going to roll 2 dice. But today, it's just considered one event or one card. Okay. If the cards were turned upside down, I want to randomly pick any heart. Well, number of wanted outcomes. What you need to think about is that there are 13 different hearts that I would be happy with. So there's 13 wanted outcomes. Remember, there's 13 of each suit. So there's 13 hearts. There's 52 total cards. So that's wanted over total possible. I have a 1 in 4 chance, or 13 out of 52, I reduce to 1/4, or a 0.25 probability of drawing a heart. Example 2, I specifically want an ace of hearts. Well, there's only 1 ace of hearts in a deck of cards, so you only have a 1 out of 52 probability or chance of drawing an ace of hearts specifically. And that's a 0.019, or you can round that to 0.02. You basically have a 1 in 52 chance. I will take the fraction or the decimal. Okay. What's the probability I draw any ace? If I have all the cards upside down and I just want to randomly pick one ace, well, there's 4 different aces. This time I'm not being specific. Okay, here I said I wanted a specific ace of hearts, and there's only 1 of those. But here I'm saying any ace, and there's 4 wanted outcomes. I'm happy with an ace of hearts, an ace of clubs, an ace of diamonds, ace of spades. So there's 4 wanted outcomes out of 52 total. That reduces to 1 in 13, or a 0.0769, or you can round it to 0.08 probability. Okay. 4 out of 52, because there's 4 aces in a deck. That's a 1 out of 13, or a roughly an 8% chance. What's the probability of a face card? For those who know what a face card is typically considered anything with a value of 10. Well, 10 has a value of 10, but so does a jack, a queen, and a king. So a face card means I would be happy with a jack or 10 jack, queen, king. Well, there's 4 10s, there's 4 jacks, there's 4 queens, there's 4 kings. So there are 16 different wanted outcomes I would be happy with. Remember, wanted outcomes, you got to really think about it. There are 16 cards I would be happy with out of 52. So that's a 4 out of 13 when you reduce it. I divide them both by 4. And that's a 0.31. You have basically a 31% chance, or a 31% probability of drawing what's called a face card. That is very relevant when you're playing blackjack or 21, okay? Because 10s are very valuable, and there actually are 16 10s, counting jack, queen, kings as 10s. So that's why you have a pretty good chance of getting a value of 10. Okay? And then I'm giving you some less than, greater than types. What's the probability of anything less than a 6? And because I said aces are always considered high or low, either one, if I say less than 6, then we're including the ace. So I would be happy with any ace, any 2, any 3, any 4, any 5, but not 6 because there's not an equal sign. I want something less than 6. So I'm happy with a 5, 4, 3, 2, or ace. Well, there's 4 aces, there's 4 2s, there's 4 3s, there's 4 4s, there's 4 5s. So there are 20 cards in a deck of cards that are less than 6 out of 52. That reduces by dividing by 4 to 5 out of 13, or approximately a 38% probability that you could randomly, blindly draw something less than 6. What's the probability of something greater than or equal to 9? Well, the wanted outcomes would be 9, because it's equal to, or a 10, or a jack, or a queen, or a king, or an ace, because ace can be considered high or low, so we are saying an ace can be considered an 11. So there's 4 of those, 4 10s, 4 jacks, 4 queens, 4 kings, 4 aces, so there's 24 possible wanted outcomes. Out of 52 total, divide by 4 and you get 6 out of 13, or a 46% probability that you can randomly draw something greater than or equal to 9. Like I said, when you're playing blackjack or 21, those are the kinds of thoughts you should have. Hey, if I need a small card, I need something less than 6, then I have a 38% chance of doing that. If I want something 10 or more, or 10, then I have a pretty decent chance of 31%. If I want something 9 or bigger, then I have a really good chance, almost half of the cards, or 46% of them, are 9 or more. Okay, you've got 6 problems at the bottom that you need to do yourself. You can either print this off and write your answer, save, and email it back to me, or you can just look at this online and then email your answer. For example, emailing 1/4 or 0.25, emailing 1/52 or 0.02 or something. Just email your answer. Preferably, I would like to see this so I know what the answer is easily, or know what the original problem is. If you have any questions, email me. I'd be happy to answer them.